Okay, in this video we're going to be talking about factoring trinomials. And there's a little part to this title which might throw some people off where it says when a is equal to 1. And you're probably thinking, what in the world does that mean? And of course that's a question mark just in case you couldn't tell. A trinomial is when you have a polynomial with 3 parts. So like for example, 3x squared plus 4x plus 5. Now remember that each part is always separated by an addition sign or subtraction sign. So I have 3 parts, part 1, 2, 3. So remember, 3 parts equal a trinomial. Now let's talk about when a is equal to 1. Now here's what I want you to kind of pay attention to, and that is first how the variables are set up. See how that is x squared and this is x, and then basically you have nothing here. So here you have x squared, here you have x, and then you have nothing. Okay. Now if you notice that all your variables when it comes to the exponents are going down. See, this is x squared, and what I'm even going down is decreasing. So that's x squared, this is x to the first power. Remember, it's always an understood 1, and then this is none at all. So you're always decreasing. There is a default way to write a trinomial. And the default way, meaning if we're just going to take all the numbers out, bring some letters into this, it would be ax squared plus bx plus c. Okay? Now, let's put some, let's just make sure we match up correctly. All right, so let me get rid of our arrows here. And let me bring in some more permanent arrows. So once again, x squared, there's your x squared, there's your x there, and there's your nothing. Okay, so a is 3, b is 4, and then c would be 5. Okay, so if I was to ask you, what does a equal in this example? Well, a is equal to 3. Well, today in this video we're talking about when a is equal to 1. So let's see what one of those look like. All right, so let's try this in a new page. So where a is equal to 1, so when we have a situation where a is equal to 1, will be something like x squared plus 5x plus 6. So in this example here, notice that a, which would be right in front of my x squared, there isn't anything, but it's always an understood 1. So this is what we're going to be talking about, is a problem that looks like this. Now what we're going to do is we're going to convert this. Remember, we're still talking about factoring here. So if you want to talk about factoring, another way to looking at it as calling it breaking up. We're breaking up the problem. And when you have a trinomial, it will look like this, where you have 2 sets of parentheses. Okay? A parenthesis with stuff in it here, a parenthesis with stuff in it here. Now, I'll even make it easier for you, because I'll tell you what will go into the first part of each parenthesis. See how this is an x squared right here? Well, if we break that up, we get xx. And so we are actually going to put one of the x's here and the other x's here. This is always going to happen when a is equal to 1. It's always going to happen. So that's going to be a dead given. So there's no reason why you can't set the problem up exactly. Okay? So let's go into a couple examples. Here's our first one. We have x squared plus 10x plus 9. Now let me zoom in just in case you guys can't see it from your computer. I'm going to zoom in a lot here. All right. Now, I know that because this is a trinomial, and because of the fact that a is equal to 1, remember there's an unseen 1 here, my answer is going to be x, or parenthesis something, and then parenthesis x something. All right, so it's going to look like this. All right, now we got to figure out what goes in the second part of our parenthesis. Well, that's where the 10 comes from, and this is where the 9 comes from. Okay, now remember, the 9 is what is called C, and the 10 is what is B. Now, what you're going to do is you're going to look for a number combination of what two numbers multiply to get to B, and yet the same two numbers add restate, I'm sorry, I messed that up. What two numbers multiply to get to C and the two numbers add to get to B? Okay, and there's always going to be one number combination. Okay, so what multiplies, in other words, what multiplies to get to 9 and then adds to get to 10? All right, now this is what I always use. I always use my C as my driving force. What are all the different ways that we can multiply to get to 9? Well, that's 1 and 9. That's one way to multiply to get to 9. Another one is 3 and 3. Okay, now if I was to take 1 and 9, if I was to take 1 and 9, and if I was to add them, I would get 10. If I was to add 3 and 3, I would get 6. So the only combination that multiplies to get to 9 and adds to get to 10 is 1 and 9. So 1 times 9 is 9. 1 plus 9 is 10. All right? Now, if you got to this point, you're about 95% there. The only thing you have to do now is take your 1 and 9 and plug them into your parenthesis. And you can plug them in any way you want to. This is a positive 1, so I would say x plus 1, x plus 9. Now you might be asking me, well, Coach Ford, what if I wrote it in like this, x plus 9, x plus 1? Would that be wrong? The answer is no. It's the same thing. You can put them in any way. Now, as a check, let me kind of get some of this erased here. And remember, you can always back up on the video. Remember what we talked about factoring, is that your original problem, which is here, and your answer is always going to be the same. Okay? So if I was to go back and reverse to get my original problem, I would just simply FOIL. And I would get my answer. And if you didn't FOIL correctly, then, or if you FOILed something and you didn't get it correct, and obviously, or if it didn't match the original problem, then obviously you have an issue, and it wasn't right. All right, so let's go ahead and get a little more difficult, or actually, let me just do a quick scan of what we're dealing with. All right, let's look at problem number 5. Okay, now in this case, we're dealing with p's, which is fine. So in this case, rather than being x's like the problem number 1, it would be p something again. Now remember, what multiplies to get to 48, yet then turns around and gets to 14? So what two numbers, I'm just going to do boxes here, what two numbers multiply to get to 48, and yet the same two numbers add to get to 14? Well, all the different ways to get to 48, let's see, we have, I'm just going to write up here, 1 and 48, 2 and 24, 3 and 16. Let's see, I think there's 4 actually works too. Yep, 4 and 12. And then let's see, I believe 6 and 8 do as well. So those are all the different ways we can multiply to get to 48. Now my question is, what adds to get to 14? Well, if I was to do the math, this gives me 49. If I add it together, this gives me 26. This gives me 19. This gives me 16. This right here gives me 14. Hey, we got a match. It's the 6 and 8. So I'm going to plug it in as plus 6, plus 8. And that's how you do it. Let's go to question number 6. Now we're going to be changing it up a little bit. What multiplies to get to 30 and then adds to get to 11? All right, now we have a negative 11, okay, and then we have a positive 30. Now what makes it difficult is the fact that this is now a negative 11. So you're going to have to go back to your number sense here, okay? So negative 11, so that means I'm going to have to deal with a negative number of some sort, okay? But if you notice, it's got to multiply to get a positive 30. So if I took a negative number and then added it to a positive, or multiplied it to a positive, there was no way that I would get a positive 30. So that means it would have, my two number combinations would have to be negatives. So what two numbers multiply to get to a positive 30, yet then the same two numbers add to get to negative 11? Okay, now just in the interest of time, I'm going to go ahead and speed it up. The answer is negative 5 and negative 6. So that means my answer would be x minus 5 in parentheses, and then x minus 6. And there's your answer. All right, let's look at question number 4. Once again, we're dealing with a negative number. But in this case, we are multiplying to get to a negative 8. So if I was to ever, let's say, if you remember, if you want to get a negative number, you have to multiply a negative times a positive. So that means we're going to be dealing with a negative and positive number combination. So what two numbers multiply to get to negative 8, yet the same two numbers add to get to positive 2? Well, what are all the different ways you can get to negative 8? So let's see, I'm going to write this in green here. All the different ways I can multiply to get to negative 8, that is negative 1 and 8. Or I could say positive 1 and negative 8. Or I could say 2 and negative 4, or negative 2 and positive 4. I believe that's it. So what are all the different ways, or what adds up to get to positive 2? Let's see. This will not add up to get to positive 2. This will not add up to get to positive 2. This right here gives me negative 2. Hey, but this one right here gives me a positive 2. So that's my number combination. Negative 2, positive 4. Well, how do you put a negative in there for your answer? Simple. X minus 2, x plus 4. And there's your answer. All right. That was question number 2. Pause the video if you want to take a look at that one. There's question number 8, question number 10. Remember, pause the video if you would like to try them, because I'm about to show you the answers in a second. And there's 7 and 8, or 7 and 9. And so the answers to these are this right here. So as you're working, I hope you checked it and you got them right. Let me know if you have any questions. Thank you.